Till now we have discussed about formal grammars. Yes, I'll just brief you a bit, then we'll move ahead with the same, topic related to this only. Any grammar is identified by 4 tuples. They are called as V, T, P, and S. Okay, what is V? V are set of variables, or what we also calling it was non-terminals. Okay, non-terminals. Then T is set of terminals, and P are the production rules, which are sometimes also called as substitution rules, because the only operation that you apply on the production rules is substitution. That's why S is the starting symbol, starting variable or symbol. It's actually a variable only, that's why we are calling it starting variable. It's a non-terminal. Okay, now one important thing, that V intersection T is equal to phi, which means there is nothing common between the variables and the terminals. 1 point. Okay, second point, the production rules. The productions rules are of the form alpha derives beta. We call it as alpha derives beta. Alpha gives beta or alpha derives beta. Okay, now condition on alpha is that alpha but itna bhi dhyan rakho. Okay, just remind this thing, keep remembrance of this thing, alpha derives beta. Okay, is this clear? Yes, till now any doubts with the grammar? What is grammar and how a grammar is identified using 4 tuples? No or yes? Am I audible? Oh, sorry. So we talked about different languages, type 3 to type 0. Yes, type 3 to type 0. Now we have already discussed type 0. Type 3. We've already discussed type 3, which is regular languages, which is also equivalent to regular expression, which is also equivalent to your finite automata. Okay, so obviously now we will discuss about type 2 grammar, which is also called as context free grammar. Okay, context free grammar, or CFG. Okay, CFG. So CFG has the same thing, V, T, P, S. Same conditions are applied. The only additional condition on P is this, that alpha only contains one variable only. Okay, alpha, which means, when we are talking of production rule, it is alpha to beta. This is the left hand side, this is the right hand side. So us tarike se, the left hand side will always have only one variable, not a combination of a variable. Or terminal to bhuli jao, terminal to aayega hi nahi. Okay, not a combination of a variable, and not at all a combination of variable or a terminal, or terminal alone to aayega hi nahi. Okay, just only one variable. Is this clear? So we'll just discuss with an example, 2 minutes. And beta can be V union T asterisk, which means beta can, on the right hand side, you can have either an epsilon, lambda, which is null. Here we consider null as this thing. You can also use epsilon here, no problem. Or you can have a combination of V union T. It can be capital A, small a, capital B, small b, and so on. we'll just discuss in just a minute. ठीक है, यहाँ तक क्लियर? ये ध्यान रखना बहुत जरूरी है that how do you identify that a grammar is contextually grammar or not is by only looking at the production rule. ठीक है, don't get confused. By only looking at the production rules, you can decide whether a grammar is CFG or not. ठीक है, clear? Sorted? I hope this is sorted. Yes or no? हेलो. आपको पता नहीं ये वीडियो YouTube पे मैं डाल देता हूँ, तो आई नीड योर रिस्पॉन्सेज ताकि पता लगे कि आप लोग भी YouTube पे बात करने लायक हो. नहीं? चलो. So an example of any production rule or a grammar. ठीक है, let's look at a example, and our main objective is to talk about something called as an ambiguous and non-ambiguous CFG. So obviously we need to first understand what is CFG, and obviously we'll have to understand how a CFG is represented. Okay. Now suppose a P is given to us like S derives 0S and 1S, 1S. So this is a pipe symbol. You know what is a pipe symbol? You know what is a pipe symbol? कीबोर्ड पे बताना पाइप सिंबल कहाँ होता है?
सर बैक स्पेस के नीचे.
बैक स्पेस के नीचे शिफ्ट दबा के यूज करेंगे.
शिफ्ट दबा के यूज होते हैं.
ठीक है. एंड S can be epsilon. So we have got two production rules. In fact, this is only one production rule. You can also put it like this, so it will still work. Okay, but I'll just keep it like this as to explain to you certain things. Okay, now this is a CFG. Okay, now this CFG is can be used to generate some strings. Obviously, it's a grammar, so grammar can be used to generate a language. Language is what? Nothing but set of strings. So we have to ultimately generate some set of strings. Now that generation of strings using the production rules utilizes something called as derivation tree. The process is called as derivation tree, or left hand side derivation or right hand side derivation. We'll just discuss what is it. But क्या होता है पहले ये देखते हैं. So as I told you that production rule is also called as substitution rule. तो यहाँ पे पहले let us identify the grammar in terms of VTPS. What is the V here? S. S is the V here. What is the terminal here? Terminal is 0, 1 and epsilon. 0, 1 and epsilon. Okay. P is already given to us, and S is the starting symbol. So the first production rule, the left hand side of the first production rule is the starting symbol only. Okay, I'll explain with another example also in which we have more than one variable or terminal. Then we'll see what is it. Okay. तो अब क्या है, कैसे है derivation? How do we create a derivation? Is just nothing but you substitute it. Substituting how? So first we see S derives 0S or 1S. You pick any of them. You choose. What do you want to pick? 0S or 1S? You guys, you choose. 0S or 1S?
0S.
0S. Sure. S can be derived as 0S. Okay. Let us go to the next page. Better. S derives 0S. This is also written to be like 0S. Okay. Now we had different options. S is either 0S or it can be 1S or it can be epsilon. Now what do you want to substitute out of these three? कुछ भी कर सकते हैं. We can substitute any of these. What do you want to substitute? Tell me. So let's substitute 1S here. 1S. So now S becomes 0, 1s. So we have just substituted this with 1s. Now this s is again left. So this s can be substituted by again 0s or 1s, whatever you choose, doesn't matter. Okay, whatever you choose, it don't matter. Now 0, 1, 0 s. Now s can, I want to just take two more, and then I'll keep it 0s again. So we've got 0, 1, 0, 0s, and then this will be further implemented as epsilon. So we'll have 0, 1, 0, 0 epsilon, which is actually 0, 1, 0, 0. So this is s, 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 s. And if you want to read it, you read it from here. It will go in this direction, and that's it. This is the direction of creating the string which can be generated using one substitution way. Okay, is this clear? How did we end up to this string? Yes or no?
So if we substitute with 1s, 0s in the starting, तब भी solution same रहता?
नहीं, अगर हम लोग स्टार्टिंग में 1s से सब्स्टिट्यूट करते तो स्ट्रिंग डिफरेंट आ जाता. It doesn't matter because you can generate multiple strings using the same grammar. In fact, you can generate infinite number of strings.
किसी पॉइंट पे हम लोग टर्मिनेट कर सकते हैं, मतलब किसी पॉइंट पे एप्सिलॉन आ सकता है.
किसी भी पॉइंट पे एप्सिलॉन आ सकता है, कोई प्रॉब्लम नहीं है. You could have also created like this 1s और यहाँ पे एप्सिलॉन. So you will have only s derives 1. That's it. This is also allowed. This is also correct. अच्छा, और देख लेते हैं. You can also substitute epsilon here. So this will become 0, 1, 0. So s derives 0, 1, 0 is also correct. Okay, but are you able to understand the methodology, how we are creating a string using the grammar? Is this clear to you? Hello? Good. Everybody, please share a yes in the chat box if it is clear to you. How to generate a string. That's it. I'm not talking much more. Kya hai string, kya nahi hai string. I'm just asking, is it clear how to derive a string from a grammar in the form of derivation tree? Good. Thank you so much.
Sir.
Thank you, Aditya. Thank you, Rohit, Rohan, Abhishek. Very good. Tanya, thank you so much. So now I'll give you example. I will give an example for you to solve it out. Okay, this is the most basic example जो हम लोग for a grammar we utilize. So that is E derives E plus E or E star E. E derives 0, 1, epsilon. Actually 0, 1 ही होगा, epsilon तो कभी भी आता नहीं, but ठीक है, no problem. Now you just derive 2, 3 different strings. What are the possible strings that you can derive? What are the possible strings that can be derived from this? Just derive 1 or 2. Just practice how to use the derivation tree.
बिल्कुल कर सकते हैं. आप you can use the reuse battery. आपको आप
सबका हो गया? समझ में आया सबको?
इसमें क्या compartments हैं?
Are you able to create it?
People used to study as a chemist student. You should have that curiosity to learn the chemical components that is there in the battery and how the battery is actually made. One modern sophisticated batteries to rechargeable battery. वो तो नहीं करना चाहिए ऐसे से, लेकिन जो है उसको यूज कर सकते हैं. These are usable. These can be used again, right? So this is the sum of this. So वहाँ पे क्या होता है?
हो गया सबका? Yes or no, guys? Hello?
Voltaic cell,
Everybody clear?
galvanic cell है जो
No, sir.
there are two compartments, there are two vessels, right? In one vessel, one type of reaction is going on. In another vessel, another type of reaction is going on. Like मैंने आपको भी दिया है, notes भी दिया है. ठीक है, तो एक कंपार्टमेंट कैथोडिक कंपार्टमेंट होता है, एक कंपार्टमेंट एनोडिक कंपार्टमेंट, राइट? वहाँ पे किस तरह का रिएक्शन होता है जरा मुझे बताएंगे आप लोग में से कोई?
ठीक है, I hope सबका हो गया, कुछ तो आया होगा. Were you able to create this? E derives 0 plus 1, 0 plus 1. Were you able to derive this thing? Can you derive 1 plus 1? Can you derive 0 plus 0? Or can you derive 0 star 1? Can you derive 1 star 1? Or 0 star 0? है ना? You can derive this, yes or no?
सर इसको ट्री की फॉर्म में नहीं कैसे करें?
ट्रिकी फॉर्म में? ओके, ट्रिकी फॉर्म में देख लेते हैं. ट्रिकी फॉर्म में हमने किया a e plus e. Now you can derive this, you can put a substitute anything in e. So I'm just keeping it so simple that I'm just putting it 0 plus this will go down, this will be 0. So you can have 0 plus 0. Similarly, if you want to put substitute 1 here, so you have 1 plus 1. Okay, is this clear to you or not?
Yes, sir.
So the idea here is variable is only e, the terminals are 0 1 plus star and epsilon. ठीक है, I think आप इस चीज में कंफ्यूज हो गए होगे, है ना? Did you get confused in this thing? कोई बात नहीं, ठीक है. As a teacher मेरा काम आपको कंफ्यूज करने का भी है, पर ठीक है, चलो समझ में अब आ गया. This is also considered as a terminal, not a part of the variable. This is also a terminal. ठीक है, चलो क्लियर होगी नहीं ये बात? ये बात क्लियर होगी. अब हम इसको थोड़ा सा सिंपल करेंगे. We'll just keep it a little simple to explain to you an extra concept called as अभी बता रहा हूँ. ID. Now the terminals here are ID plus and star. Okay, so IDs can have 0 to 9. It can have a value from 0 to 9. It can be anything, मतलब 0 to 9 मतलब plus minus anything. ठीक है, you can have anything. ठीक है. Now let's just see one thing. There is a thing called as leftmost derivation, and there is a thing called as rightmost derivation. Okay, now what is it? पहले ये देखते हैं. So just look at this production. E derives E plus E. Okay. Now the question when we talk about leftmost derivation means if in the right hand side you have more than one variables, then you will always reduce, substitute बोलते हैं, but reduce भी बोलते हैं. You will always reduce or derive the leftmost variable first, and then you will go on deriving the whole string from left to right. Okay. Now suppose if I want to substitute E with this left E, only this left E will be derived as E star E plus E. So this plus E is here, this E is now this thing. Okay, this E is now this thing. Okay, is this clear? Now if I have to substitute again, I will only use left one, not the middle one, not the right one, the left one. Suppose I want to do this, so I'll just keep it ID here. Okay, now suppose if I want to substitute this also, ID star ID यहाँ पे भी मैंने id से कर दिया और यहाँ पे भी मैंने id से कर दिया, ठीक है. Just two stages of the tree. I don't want to make it more complicated, just to make you understand what is leftmost derivation. Let it be more clear. id star e plus e. Next step will be id star id plus e, and then this will be id star id plus id. Now this id can be anything. Id can be 3 plus 2, sorry, 3 star 2 plus 5, or any number, doesn't matter for us right now. It's important that this type of a string can be generated using this leftmost derivation. Leftmost derivation. Is this clear? Yes or no? Is this clear? Hello.
Yes, sir.
Yes, sir. ठीक है. Now, what was about the rightmost derivation? Now, rightmost derivation के लिए भी हम लोग same लेते हैं. चलो, e plus hold on, हमने कौन सा लिया था पहले? e plus e लिया था, ठीक है. तो अभी हम फिर से e plus e ले लेते हैं. e plus e. Now, rightmost derivation means, obviously, according to the definition of leftmost derivation, you can define that rightmost derivation means you first reduce the rightmost variable and then you go into the left direction. Okay, so how do you do that? Just taking an example. Okay, e plus e star e. You can also substitute e plus e, कुछ भी सब्स्टिट्यूट कर सकते हो, कोई रोक नहीं कर रहा आपको, बट मैं आपको एग्जांपल देके बता, ठीक है. यू कैन यूज एनी ऑफ द थिंग्स. सो आई जस्ट पुट इट इन द राइट हैंड साइड सो दैट इट इज क्लियर इन टर्म्स ऑफ टू डिफरेंट एग्जांपल्स वी आर टेकिंग. This is one situation, this is another situation, okay, in which only the right hand side part has been substituted. Now obviously if you have to substitute id, so in terms of rightmost derivation, then it will be this thing. In terms of right one, this will be this thing. Is this clear? ठीक है, क्लियर हुआ? क्लियर हुआ? इसी को अगर ट्री फॉर्म में लिखेंगे ना तो ऐसे लिखेंगे e derives e plus e, ठीक है. Rightmost derivation, so e star e, and मैं id substitute करना चाहता हूँ, ठीक है. तो this will be id and then this will be id and then this will be id, ठीक है. Just make sure rightmost derivation का मतलब सिर्फ it is only utilized to reduce the rightmost variable, but when you are looking at the string, it will always move from left to right always. Okay, so it will be id plus id star id. क्लियर हुआ? क्लियर हुआ? Yes or no? Yes or no? Hello? ठीक है, हो गया?
Yes, sir.
Yes sir, yes sir. Good. चलो, now this tree is also called as something called as parse tree or derivation tree. Derivation tree तो मैंने आपको पहले बता दिया था, but it is also called as a parse tree. Okay, so this should be clear. Obviously, since this is leftmost derivation, so this will become this will become rightmost derivation or rightmost parse tree. Similarly, this will become leftmost derivation tree or leftmost parse tree, LMPT or LMDT, कुछ भी. There are certain documents or certain websites which are using this thing. So I'm just explaining to you, okay, what is it exactly called, or how do we come to talk about leftmost derivation tree or parse tree. Okay. So now the main question which we had to discuss today was ambiguous grammar. Now, ambiguous grammar, what does it mean? For a given string, or any string that you can think of from the language, for the language, if lm dt is equivalent to rm dt, or you can say that if you can create or design a rightmost derivation for the same string and a leftmost derivation for the same string, then this grammar is called as an ambiguous grammar. Okay, then this thing is called as ambiguous grammar. Now let's see in the example जो हमने अभी किया है. Our example was e plus e, e star e, and id. Now suppose I want to generate a string id star id plus id. Okay, so I can create this id star id plus id in different ways. Okay, so I can either substitute e with e plus e, or I can substitute e with e star e. Yes or no? Yes or no? Now, if I want to generate this string, this is my goal, this is my output, this is my desired output. So I will use left one to substitute with e star e, and then this will come plus e, and then this will be id star. I mean, when I'm just making arrow, it doesn't mean that it is a tree. It is actually written like this only, e plus, and then this is the next line in the page. This will be e id star e plus e, and then you do id star id plus e, and then you do id star id plus id. Okay, so what kind of derivation is this? This is leftmost or rightmost? Leftmost. So this is leftmost derivation, LMD. Now we will talk about this thing. So if I have to generate this one, तो मैं क्या करूँगा? Please tell me, what will I have to substitute? I will have to substitute this e with e plus e, है ना? E star,
Yes,
e plus e. ठीक है? And then e star e plus id, then e star id plus id, and it will be e star, sorry, it will be id star id plus id. This is what derivation? This is rightmost derivation. Rightmost derivation. Now we can see that both of the derivation are different. Yes, I mean the derivations are different, but they can result in the same string. Okay, they can result in the same string, so they are equivalent. Hence, given grammar is ambiguous. Okay, okay.
So what is the amount?
बहुत important है समझना. Is this clear? We will ask you a question. Normally यही similar question ही आता है, यही इस तरीके का question आता है. Instead of ID, it might be A or B, 0 or 1, or just ID, or exacts this question, doesn't matter. But you have to prove, the question will be asked, prove that this grammar is ambiguous. Okay, so how will you prove? You will create two different derivations, leftmost and rightmost. Just pick up any example string. So मैंने अभी ये वाला example है. You can also pick up this example, ID plus ID star ID. You can also pick up this thing. Up to your choice, doesn't matter. Okay? Then you do two different derivations and you show that we can generate the same string using the different derivations. So it becomes ambiguous. Yes or no? Is this clear?
yes, sir.
Yes, sir.
Obviously, what is an unambiguous? Unambiguous will be
Not equal.
Which is not
not equal. which means which is not equal, but one important aspect is for any string only one type of derivation tree can be utilized. ठीक है? ठीक है जी? Sorted. So we'll discuss something called as unambiguous to ambiguous grammar. How do we reduce the ambiguity in a grammar using certain processes? वो हम लोग फिर कभी discuss करेंगे. एक और process होता है इसमें. But till now, today for this lecture, is this clear to everybody? What is a grammar? What is derivation? What is CFG? Okay.
Yes, sir.
So this is this CFG. This is a CFG. CFG is ambiguous or unambiguous. Okay. So we'll just do that. Okay. Achha, please share the screenshot. Take the screenshot.
10 million is equal to 100 lakh. 100 lakh we have to multiply by 72.
ले लिया आपने screenshot ले लिया?
Okay. So don't think that there is not a huge.
Just a minute, sir. मैं ले रहा हूँ.
हाँ.
That money is just.
Okay. So we'll close the session. If anybody has any doubts, you can always connect with me. अभी भी आप पूछ सकते हो, कोई दिक्कत नहीं है.
It is a discovery. The discovery which will actually benefit the whole world. Right? The
Done.
discovery which leads
Done.
to the benefit
Sorted. So ठीक है, then we'll close the session and we'll meet in the next lecture. ठीक है? Thank you so much, guys. All the best.
Thank you, sir.
Thank you, sir.